Channel. This is Expert Funda and you're watching on YouTube. So today we are solving a super interesting problem from Leetcode. So this is a daily contest question, and Leetcode question is saying count subarrays where max element appears at least k times. Okay, means count subarray where the max element appears at least k times. So let's not just jump into the code. We will first build the right intuition together, and then we'll try to understand the problem. Then we'll go through the intuition, then we'll try to write the code. Okay, so you are given an integer array nums and a positive integer k. We have to return the number of subarrays where the maximum element of the nums appears at least k times in that subarray. So subarray is continuous sequence of element in an within an array, right? And we have given an example. So sub arrays we have given and k we have given, our output we have given. Okay, so the problem statement, you pause this video and go through so that you will have the clear understanding. And let's begin. So the problem understanding part is very important. So what we have given here, that you have to understand. So we are given an array of integers, first of all, as you can see, and a number k. We need to count how many subarrays have the maximum element appearing at least k times. Appearing at least k times, right? Appearing at least k times. What we have to do? We need to count how many subarrays have the maximum elements appearing at least k times in the subarray, right? So instead of checking every subarray manually, what we should do? Just think, right? That is called intuition, right? So for the example that we have given here, you can see nums we have given, k we have given, and output is 6. How it is coming? So the subarray that contains the element 3 at least 2 times are these, and these, right? As you can see. So, okay. So how many are there? 1, 2, 3, 4, 5, 6, and so it is coming 6, right? The subarray that contains 3 at least 2 times. This subarray, this subarray, this subarray, this subarray, this subarray contains at least 2 times, right? So what we should do, right? Means we have to think about the intuition, like we should go with two array, two loop with the subarray to check, right? Or how we are thinking, right? So instead of checking every subarray manually, which would be slow, right? We are going to use a sliding window approach, right? So why we are going to do that? Because see, the first will find the maximum number in the entire array, right? If you are aware with the study problem, right, from the daily contest question, right, I have created a sliding window approach based solution, right? Or you can say 2-pointer based solution, right, in which we have discussed how sliding window works, right? So now we are doing the same. We are going to use a sliding window approach in this problem. And so the first, we have to find the maximum number in the entire array, right? So as we slide a window across the array, we count how many times the maximum number appears inside, right? So you will slide the window in the array and then you will check, right, how many times the number appears inside. So as soon as we reach, let's suppose for this array, how we are going to how we slide a window, right? Let's suppose. So first of all, the window is 1, 3, 2, 3. From here to here, we are not taking 3, this last 3. So the first subarray is this 1, 3, 2, 3. We are not taking the last one, and so it is coming 2 times. So we can take 1 as count, will take a count 1. Then we'll take whole array, right? Then we take last 3 to 3. We will shrink it and we'll take 3 to 3. So in this, similarly, we'll keep sliding, right? we keep sliding the window across the array, in this array, right? And we count how many times the number appears. 3 appears 2 times, here, 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 and so it is coming 6 times, and so we will return the 6 times. So as soon as it appears k times, we know that all the subarray starting earlier and ending at this point are valid. Correct? As you can see the explanation, right? So we'll carefully track and move the left pointer and to make it efficient, right? That we will do. Okay. So we are saying we are asked, what we are asked, count the subarray where the maximum element appears at least k times, right? Then what we have to do, first we will find the value in the array, we can say max val, and for every subarray we need to check what does it have at least k times. If it is 10 times, we'll increase the count, but checking every subarray individually will take offense care, right? That we will very slow, right? For 10 to the power 5, right? So we will use sliding window, right? So how we can optimize it? Use the sliding window technique, right? So the focus on the subarray is use the sliding window and keep the count of how many times max val appears inside the window. So as soon as we have k or more max vals inside the window, every subarray starting from the earlier position is valid, and so expand the right and move the left when needed. Gotcha? So the first step is to find the max value in the array, right? Maximum value in the array. Use the 2 pointer left and right for the sliding window. Expand the right? Start counting how many times the maximum number appears. Shrink from the left when the window has enough maximum numbers. Count all the valid subarray by adding left to our result, and that's all. That is very simple, right? So let's suppose we have given this example, right? And so what is the max value? Max value is 3, right? What is the max value? Max value is 3. So we'll do the sliding idea. As you know, we will move when count 3s. 3s is greater than or equal to 2. So you can perform valid subarray, right? As you know, how many 3s is there? 1, 2, 3. 3s is there. 3 is 3 times, right? And it is greater than or equal to 2. So we can perform the valid subarray, right? So this is the idea. Okay. So for each right index, we'll move left as small as possible, so that between left and right you have at least k time max vals. Then all the subarray starting to left to right are valid. Means first of all our idea is to find the max val. If max val is there and it is greater than or equal to 2 or k, means we can perform it, right? So this is your key idea for each index, for each right index, right? Move left as small as possible, so that between left and right you have at least k max vals, and then all the subarray starting from left to right are valid, right? So let's walk through the code so you will understand. Okay. So first step is to find the maximum value in the array. How we are going to find the max val? So you can take integer.mean value, and so you can find the max val, right? So you will take the max val and iterate over the array and take math.max. You pass the element and the max val value, and you will have the max val updated once you will iterate over the array. Then take the step 2, slide window, right? You do the sliding window here. So for the sliding window, you will take the left is 0 and answer will take 0 and will return answer at the last. Then we'll take count, max count, number of max val in the current window. We'll take a for loop. We'll start from right is 0. If right is less than this, means we are taking the sliding window. So one will take the left side, another will the right? So from the right, we'll keep from 0 to the last, right? How will expand the window? We'll expand the window and we'll check nums at right equal to the max. If it is equal to the max value, means increase the count plus. Okay, count max plus. Now how will shrink the window? We'll shrink the window from the left if needed, right? So we'll check if max count is greater than or equal to k, right? In that case, we'll check nums at left equal to the max value. If it is equal to the max value, we'll do count minus minus, and then increase the left plus plus, means from the left side we'll shrink it. Okay, so we'll shrink from the left, right? If it is needed, we'll check if count max is greater than equal to k and nums left equal to max value, right? Remember, right? The count max, you understand the count max, right? So we'll find the max value. What is the max value? Max value, how many numbers times you have the max value here, means 3 is 3 times, right, in the array. So if nums at right index is equal to 3, means we'll increase the count plus plus, max count max is plus plus, right? Then if count max is greater than equal to k, right, it's time to shrink it. Why it is time to shrink it? Because see, it is greater than and equal to, means it's time to shrink the window. Means why we are taking all the 3, right? We can shrink it, right? And so that nums at left equal to max value, if it is there, nums at left equal to the max value, let's suppose it is 3, right? Then we'll decrease the max count. Okay, and then we'll move the left plus plus, we shrink the window. To shrink the window, we'll do left plus plus, means we are exceeding that element that is at the nums at left, right? And so we'll update our answer. How? Answer plus equal to left, right? So add the number of valid subarray ending at the current right? And so our answer is getting updated, and so you will return the final result. Okay, so what are the steps are there? The first step is to find the max value in the array, then do the sliding window, then expand the right window, then shrink the window if needed, and then finally add the number of valid subarray ending at the current right, and then return the answer. Okay, so this is the approach, right? We are using sliding window and count max occurrence, how many occurrence is there, and to find the occurrence, right, we are iterating all the arrays, right? And for each move, carefully update how many valid subarray exist. So it will take O of n times. As you can see, there is only one loop is there, and that is a super optimized code. So I hope you like this video. If this video is helpful, please hit subscribe this channel, and let me know if you need any problem solved, right? Thank you for watching this video, guys. I'll see you in the next one.